I'll be introducing you to a research-backed technique for prompting your AI agents, which is meta-prompting. With meta-prompting, you'll be able to build more powerful and flexible AI agents with fewer prompts to manage yourself. In this video, I'll explore with you what meta-prompting is, and then I will demonstrate to you my own implementation of a meta-prompting agent that I've created with LangGraph. The GitHub repository for the agent will be available to you, and it's linked in the description to this video. So feel free to check that out if you wish. All right, let's get into technical details. Let's start off with understanding what meta-prompting is. So I'm going to read verbatim from the notes I've created here. Meta-prompting is a scaffolding technique that turns a single large language model into an orchestrator managing multiple specialist large language models. So if you imagine, right, that large language model that's acting as your meta prompter or your orchestrator large language model is a generalist model. It will be the most powerful model in your model stack. And that model, you prompt to write instructions for the specialist models. That's how meta prompting works. That's the whole magic behind it. So ordinarily in your multi-agent workflows, if you have been building with agents, you might have written the prompts for every single agent to do a particular thing. So you might write a prompt for a web search agent. You might write a prompt for a research agent. You might write a prompt for a coding agent. With meta prompting, it's a bit of a paradigm shift. Instead of writing the prompts for every single agent, what you do is you write a prompt for the orchestrator agent, which does two things. You ask the agent to give instructions to the specialist agents. So write prompts for the specialist agents. And you ask the agent to also output a final answer when it has gathered enough data from its specialist agents. So that's how meta prompting works. So now I want to show you an example of a meta prompt that I've written for my own implementation of a meta prompting based agent. So let's have a look at that. We can find that. I believe I've linked it in my notes somewhere down here at the bottom. Here we go. If I jump straight to the meta prompt. So there's a few tricks here that I'd like to share with you that I found useful. So first of all, when I was writing this meta prompt, I wrote it in Markdown. That's a trick I've learned doing my own research on prompt engineering. There's a few people in the community that also write their prompts in Markdown. Well, there's a lot of people that write their prompts in Markdown. And the reason for that is A, it makes it a lot easier to read the prompts. So you can see the prompt I have on screen now. It's a lot easier to read. And secondly, you can imagine that a lot of these large language models have been trained on tons of Markdown. So it's a good way of expressing instructions to large language models. And I've found it to work well. Right. So this is what you're looking at on screen now is the actual meta prompt that I've used for prompting my own implementation of this meta prompting agent. So the first thing here, you'll recognize as the persona. So it just says you are a meta expert, a super intelligent AI with the ability to collaborate with multiple experts to tackle any task and solve complex problems. You have access to various tools through your experts. And then we'll talk about the objective. Your objective is to collaborate with your team of experts to answer queries coming from a human user. The queries coming from the user will be presented between the tags. So I'll show you what those tags look like. I have to go to edit mode to show that. So you can see the tags that we've presented in these problem tags. So I'm not going to read every detail of this prompt, but I want you to understand the main aspects of this prompt. So here it is under how to achieve your objective. So as meta expert, you are constrained to producing only two types of work. Type 1 works are instructions you deliver to your experts. So that's key. So these are prompts that this agent is going to deliver to the experts. Type 2 works are final responses to the user query. So once we have gathered enough data, you get your final response. This meta prompting agent can then deliver a final response to the user query if it believes enough data has been gathered. So here are the instructions for producing type 1 works. So you can see the kind of thing we're looking for. It will respond with, if there's a question that requires internet search, it will give instructions to an expert internet researcher. And these are the instructions. They said, find the current weather conditions in London, and see it generates this prompt by itself. And then you've got instructions for producing type 2 works. So this is where we deliver a final answer, and the meta prompter will deliver it like this. I've also given it some information about the experts that it's working with. So here, there's some information about the types of experts that we're working with here. And what I've mentioned crucially is that, this is the designated team of experts we have: expert internet researcher, planner, writer, reviewer, data analyst. But if there are any experts that it believes that it needs to hire, in quotes, then the metaprompter can create the expert. And I've told the metaprompter exactly how to create an expert. So to do this, you simply create type 1 work with the instructions for and name of the expert you wish to hire. So it can make up an expert that doesn't already exist here. And then I've given it some information about expert work and how that will be presented. So when the experts present a response, it will be presented within these tags. Then there's some best practices for working with the experts. You can go through this and read this in your own time because I'm going to be supplying the prompts for you. Now, here's the thing that I found to be key to getting the meta prompting to work: providing example workflows. So I've done this with a single shot example. I've just given one example of a meta prompting workflow where the human query is, what is the weather forecast in London? The meta prompter goes on to produce type 1 work. Here's what the meta prompter produces. So this is the instructions for the expert. So expert internet researcher. And these are the instructions. Find the current weather forecast for London, UK. So it says include temperature, weather conditions, humidity, so on and so forth. Use only reliable and up-to-date weather sources. So the internet researcher goes away and finds a source with all of the information. And there we go. There's what it is. Our metaprompter digests that and delivers our final answer. So that is making use of the in-context learning that is inherent to these generalist large language models. And what's brilliant about this is because large language models, context window is growing each month, it seems. We've got models that can process up to 1 million tokens now. And, you can see 32,000 tokens as a standard. That gives you a lot of room to provide examples of workflows, which should make your metaprompter work more effectively. So that's what's brilliant about this. I see a lot of opportunities as we release more powerful models to have these super powerful metaprompters that can create these really flexible task agnostic workflows. Okay. And then we've got some important reminders. So that is the prompt. That's the entire prompt as I will be feeding it into my own implementation. Now that I've talked through the meta prompt that I'm using, I want to show you quickly how it works in the Anthropic workbench that I've set up. So I'm going to start by copying all of this out. Just highlight everything there, copy it out all the way to the top, Control C. And then I'm going to open up my Anthropic workbench. I have an old example in here already, but I'll get rid of that. So I'm going to paste the latest into my system prompt. You can see we have everything in there. And then let's come up with a problem. So let me come up with a problem, first of all, that doesn't require any use of the internet. So let's say, write me a ghost story. And then we'll hit run. So just to show you, I'm using the Claude 3.5 Sonnet model. Temperature is set at 0. And remember, this isn't going to do anything but just test this prompt so you can see how this works in reality. So if I hit run on that, you'll see the response come up. So there we go. So you can see what this meta prompt has done is it's given the task to an expert writer and it's given it a prompt. So it says, task, create a compelling ghost story with the following elements. There you go. The story should be approximately 500 to 700 words, blah, blah, blah. Let's see another example that might require something from the internet. I need an extensive piece of research on the multi-agent framework mixture of agents. I need it sourced with relevant information. Sorry, I need it sourced with not relevant information, with reputable journals. Let's do that. Okay. So if I run that prompt, there we go. So identified that it needs the expert internet researcher. And then we've got a task here. And you can see it's captured everything I need within that task. So we have created another expert, the expert internet researcher, that's different from the expert that we needed to write a ghost story. And you can assign these to LLMs and they will go off and complete these tasks. Let's talk a little bit about my own implementation of a meta prompting agent. So I've got a meta prompting agent for web search. Look, the reason I'm doing web search is I've got a lot of the infrastructure there already, and it's something that's quick and easy to stand up. I know there's other examples of agents that I could build. I would probably seek to build those in other videos. Just let me know in the comments section if there's another type of agent that you'd like to see. But I feel web search demonstrates this meta prompting approach really well. So meta prompting with web search, the framework I'm using to orchestrate the agents is LangGraph. And I like LangGraph because it is flexible and customizable. There is a learning curve to LangGraph, and I've made a video in the past introducing LangGraph and some of the key topics that you need to understand and the philosophy around the framework. If you're not familiar with LangGraph and you would like to know about it, check out the video I made earlier. So I'll link that somewhere in this video. Now, what I like about meta prompting is that the number of instances of agent that you need to build in any type of implementation, any type of agent workflow, agentic workflow is quite small. It's essentially just, I've identified it as 3 agents for this implementation. So the first agent is the agent that takes the meta prompt, or the prompts, the meta prompting agent. So you can see that here where we have the meta expert. The other 2 agents are your experts. So there's 2 types of expert. And this is just the way I've formulated this in my own implementation. So you have an expert that has access to tools, and you can make that tool set as deep as you want. And you have an expert that doesn't have any access to tools, but is just a separate large language model instance. So those are your 3 experts. And then obviously you have a router here as well. So what happens is the query is given by user. The meta expert looks at that query. If it's a final answer, then it will deliver a final answer and it ends the process. If not, it delivers an instruction to an expert, and that is reviewed by the meta expert. And that process iterates until there is a final answer delivered. It's really as simple as that. Obviously, the LangChain implementation requires you to set these things up as nodes. So you'll see how I've done that when I go through the code for the LangChain, for the LangGraph implementation. But it is really as simple as that. On the surface, there's a meta prompter, there's a meta expert, and then there are 2 types of experts. There's a tool expert and a non-tool using expert, and that is it. We circulate that workflow until we deliver a response to the question. And like I said, what's fantastic about meta prompting is this is incredibly flexible. You can ask a question that doesn't require any access or use of tools, and it will use the non-tool expert and whichever expert it creates. Or it will ask a question that does require use of tools, and it will use the tool expert to do that. And that will become more clear as I show you the example. That's it for the approach. I'm going to come on to strengths and weaknesses of meta prompting at the end of the video. But before then, I'd like to first walk through a bit of the Python code I've used to set up my implementation, and then I will show you some examples of how it works live. Okay, I'm going to walk you through some of the Python code that I've used to set up my implementation of this meta prompting agent. Now, there is quite a lot of code here. There's quite a few different scripts and helper functions and classes that I've set up to make this work. I'm not going to take you through all of that. Instead, I'm just going to focus on the main script, which runs the meta prompting agent. I'll show you how I've set it up with LangGraph, and I'll show you how that runs. I'll give you an example or a few examples of how that runs after I've gone through the code. So there will be setup instructions in the GitHub repo. So if you do want to use this for yourself, I'll provide those setup instructions in the README. So just go and check that out if you want to use this project for yourself. All right. So the main script here is in the agents folder, and it's the meta agent.py. And the way this is set up is using the LangGraph workflow, which sets a graph of agents, and that determines the operation of each agent in that network. And then the other thing we set is a state, and the state acts as a memory for the agent. So it records the results of all of the interactions in the agent network, and that can be referred to at various points in your agent workflow. So right at the top here, we define our state. And you can see here, there's a state for the meta prompt. So these are the instructions that the meta prompting agent will give to the experts. There's a state for the conversation history. So I write back all of the outputs from the experts to this conversation history key. There's a state for the user input. So this is simply just the first query that comes in. And then we record things like the router decisions. There are some obsolete ones here that I haven't yet baked in. So things like chat limit, I'll bake that in at a later point when I'm looking to add some functionality to this. And then there's a state to identify when the chat's finished. Right. So there's various functions here that just help with the overall workflow. And you can get into the details of how those work when you review this for yourself. I'm going to zoom in a little bit here, just to help. Okay. So all of the agents within the network are defined as classes, and then we initialize an agent object. So the first one is the meta expert. Rather self-explanatory. We know what the meta expert is doing. It's writing instructions for the other experts. And there's a set of defined methods here that we have with the meta expert. So, getting the prompt, which we're reading from the Markdown. We have to process the responses in a certain way, and you can follow this through to see how that works. Getting our conversation history, getting the user input, and then finally we run that meta expert. We have the same for our experts. So we have just two types of expert. We have a no tool expert, and you can see the class here for no tool expert setup. And it's almost the same as the meta expert, with the one exception that the prompt that we get comes from the meta expert. So this is read from the state. You can see there, meta prompt. So that's the prompt that the no tool expert receives. It doesn't receive the prompt doesn't receive the system prompt that the meta expert has received. It receives the prompts generated by the meta expert, which are written to the state here. And, we have all of the other methods, and then we run that no tool expert. And then we have a tool expert. And tool expert does get a little more complex. You can make these tool experts as deep as you want, really, with different types of tools they have access to and all sorts of things. This is just a basic implementation. It's fairly rigid because it only has access to the internet, and that's it. So to do that, a lot of the methods are largely the same. We're picking up the prompts from the meta prompts, because remember, that's coming from the meta expert. We're formatting our responses here. Remember, none of the experts actually have access to the history. So the way this thing is set up, only the meta expert has access to the entire conversation history. Each time the meta expert interacts with an expert, it's like it's starting a new conversation with that expert. So it's like it's bringing a fresh pair of eyes. So that's kind of important in the meta prompting framework to mention too. And here's where it gets a bit more complex, because we need a way to successfully use the internet, right? So we have this use tools method, and I've defined a search engine results page method that brings back a search engine results page, and also a scraper that can scrape both PDF and HTML content from the internet. So when we're running it, there is actually several routers that are embedded within the tool expert. So the first router takes what the meta expert has provided and refines it to get a search engine result. So it refines it to get a search engine query. Now, obviously, this isn't necessarily the most ideal way of doing things, because the meta expert does tend to provide quite detailed instructions. So refining that down to one search query could, it could essentially either bring back the wrong results for more complex queries, or result in having to do multiple turns with the internet research expert agent, or the tool agent in this case. So I know that's not the most ideal way to do it, but it is a way to get this system working. So yeah, the first step is a router step. And it's not technically a router, but the first step is a refining step, which takes what the meta expert has given to this tool agent and refines it to be able to be used as a search query in Google. The second step is to identify the best URL from the search engine results page that has been picked, and also detect what type of URL we're looking at. So is it leading to a PDF or is it an HTML? And then we're writing a bunch of these things to the state. So that's after we've called all of our previous. So we're refining our search query here, and then we are getting our best URL here. And after that, we are writing to the state. So we're updating the state. And in this case, the state we're going to be updating is obviously the chat history or the conversation history, which will have the research from our expert in that state. So that can be picked up later on by the meta expert who has access to everything in the state, or has access to the conversation history as I've defined, because some of the things in the state are superfluous. They don't really make a difference for it to have access to, but it has access to the conversation history. And then you can, I realized this was a bit rushed going through the tool expert. There is a lot of code here and there is a lot of boilerplate type stuff, but you can go through this in more detail yourself. I'm sure there's more efficient ways to do this. This is the way I put things together for now. Then the final agent in this workflow is the router. And the router has one purpose. The router sits between the meta expert and the other experts. And the router will decide, okay, does this query that the meta expert produced need to go to a no tool agent, or does it need to go to a tool agent, or is it a final response from the meta expert? And does that mean that we can just produce a final response to the user? So that's the sole purpose of the router. And you can see how I've set that up here. So it says if your manager response suggests a tool might be required to answer the query, return tool expert. If your manager's response suggests no tool is required to answer the query, return no tool expert. If your manager's response suggests they have provided a final answer, return end chat. And that's what a router agent does. Now, there are probably ways to optimize the routing, and there are probably ways to optimize the internet search piece. And it'll be interesting to get your thoughts on that in the comments if you can see any ways to optimize that to make this a more effective approach. Lastly, we want to put everything together. So this project works with Grok. It works with OpenAI, Anthropic, Gemini. You can also bring your own large language model if you are setting up a VLLM inference server, and you can also use Ollama. However, I would say to you that I've only really managed to get the workflow to do anything like what it should with the Claude 3.5 Sonnet model and the GPT-4 Omni model. So I think some of those other models at the minute, you can give them a try yourself, but I doubt you're going to be able to get the results that you want. So when you're working in here for yourself, just simply comment out which model or which server you want to work with, or uncomment which server you want to work with and comment out the rest. So these are just the quads, the keyword arguments that feed in to the framework. We have our routing function defined. So remember, based on the output from the meta agent, we route the network to go in one of three directions, either to a tool expert, no tool expert, or we end the chat and deliver a final answer. So this is routing function helps to do that. Then we set up our graph. So this is our graph, and we use the state graph object from LangGraph. We're adding each node to the graph. So we have the meta expert, followed by the router, then the no tool expert, the tool expert, and the end chat. And that's it. Those are the only agents we have. And technically the end chat is not even an agent. It's just an endpoint to be able to finish the workflow. We set our entry point, which is the meta expert, and we set our finish point, which is the end chat. Then we define our edges. And remember, edges are the links between agents, and they show you how agents can communicate with each other. So if two agents are linked by an edge, they can communicate with each other. So the meta expert can communicate with the router. The tool expert can communicate back to the meta expert, and so can the no tool expert. And then the router decides based on the routing function, whether we go to the tool expert, the no tool expert, or the end chat. And once we end chat, we deliver a final answer. That's it. We can compile that workflow and we can run it, and we can test it out with various queries. I'll show you where I've put a prompt. So that's in prompt engineering. And you can see it there as a markdown. So this is the same prompt that we investigated together earlier in the video. You can see that prompt here as a markdown. Now, I want to show you in contrast the last web search agent I created where I wasn't using meta prompting. And I want to show you specifically the prompts that I had to write for each agent. So I'm going to bring that up now. So I had a file prompts.py, and I'll bring that up so you can see it. But if you scroll to the top, what you'll see here is there's a prompt template for every agent. So we've got a planner, we've got a selector, we've got a reporter, and we've got a reviewer. And also a router in here as well. So the point with meta prompting is that your meta agent will come up with these prompts by itself, right? So you no longer need to define every single prompt for every single agent that you want to take on a task. You rely on the meta agent to be intelligent enough to be able to create those prompts, and then they can be used by your network downstream. And that also means, if you have a look at the agent graph for this last web search agent that I made, I had to rigidly define all of those agents in our network. So you can see here where I've done that. So you've got a planner, a selector, reporter, all rigidly defined. So we're adding these to the graph reviewer. There's a lot more agents in this graph. With the meta prompting approach, I just have two experts. I have a no tool expert, so an expert that doesn't have access to any tools, and a tool expert. And technically, if you had one really large class that could handle no tool requests and tool requests, you wouldn't even need to have two separate expert nodes on your graph. You could just have one. But in this case, I've separated it out. So I have a no tool expert and a tool expert. And that's it. And your meta prompting agent will generate the prompts for your no tool expert, which could be a variety of things. It could be a writer. It could be a storyteller. It could be a reviewer. It could be anything. And your tool expert, which will be an internet web search agent in this case. That's it for the code side of things. Now that that's done, I think it's worthwhile jumping into a few examples so you can see how this tool works live. All right, let's give this meta expert a try. Let's see how it actually runs. So I've put some logging in place, and that logging is going to produce the state and things of that nature to the terminal. So forgive me if the terminal does get a little convoluted. It does help in actually seeing what's going on behind the scenes. I've set the logging level to info. I'll actually double check that. I believe last time I had a look, it was set to info. I can see it by just navigating to the top here. Yeah, so the login level is set to info. So it's going to deliver some minimal outputs of certain key functions here. You can play around with this yourself. You can set to debug to deliver more verbose outputs. And if you want to also manage those outputs, you just apply this log decorator to whatever component you wish to monitor. So right now I'm monitoring the conversation history. So you'll see the outputs of the conversation history, and that's why it's going to grow massively. And I'm also monitoring the run method for the meta agent. So you're going to see those two things in the terminal. To get up and running, once you're in the root directory containing the folder for the meta expert, you just run -m, and the module you're looking for is agents.meta agent. And that's going to bring up an input box. And from there, you can ask any query you want. So right now, this is running on GPT-4 Omni, I believe. We can start off with something simple. Me a short poem, right? So let's see how our meta expert deals with that. So you can see our agent trace. I'm going to let it run all the way through before I talk through what's happened. So we have our final response. We have our short poem, but let's just have a look at that agent trace. So we have our user query, ask me anything. So you can see here, let's see if we have the state actually outputted here. So we're not, here we go. So we have the state outputted here. So initially you can see, looking at the state, the meta prompt doesn't have anything in there. Initially, yeah, the meta prompt has generated something. So it says, write a short, evocative poem. So you can see it's assigned it to an expert writer. You can see that here. Write a short, evocative poem. The poem should capture a moment of or emotion vividly and be no more than 8 lines. Aim for a blend of imagery and feeling. So there we go. So this is the state, no conversation history yet. You can see the user input, write me a short poem, no router decisions, all of that type of stuff. So we progress and we can see our router has routed it to the no tool expert. We don't need the tool to write the poem. And then we can see the expert data. So this is the response coming back from the poem expert. And that's run all the way through. And you see the state is starting to grow now because now we've got some conversation history in there, which is the poem coming back from the expert. We can see the router decision here. That's run all the way through. And then we've diverted back to the no tool expert. So I think there is something in this meta prompting that gets it to kind of reevaluate the response that comes back from any expert before it decides to finally give a final answer. We can see we've got actually a different poem here. So we've got 2 poems. We've got Whispers of Love. It's actually the same poem. So it's just the experts just delivered back the same poem again. That's fine. And you can see all of that process run through. I'm not going to go through all of the outputs here because it is starting to get a little bit convoluted, but it's just for your own understanding of what's happening. But we've delivered a final answer. And there we go. There is our poem. You can see the poem outputted here from the meta agent as a final answer. So I'm not going to read the poem because I'm not a poet, but hopefully that should give you an understanding of how this thing works. Now let's try something that might require a tool. Let's say something like, is it going to rain today in London? Let's see how well that translates. So it's correctly identified. We need a tool expert. This will move fairly fast, so I'm going to keep it up here for now. So you can see the meta prompt that says after the query is it going to rain today in London? And it's generated the expert internet researcher, and it said, find the current weather forecast for London, UK for today, include probability of rain, expected weather conditions. That's what it's generated. So I have tested these weather ones in the past, and sometimes I find that it kind of gets stuck in an iterative loop of, even though it's correctly found the weather, it doesn't just return the weather as you might wish. But anyway, let's see what it does. So we've called the tool expert, and you can see we've actually gone on to the Met Office and scraped some weather data from the Met Office. And we'll pass through that. It's updating the conversation history. You can see that state is growing. And there we go. We get a final answer delivered. So based on the most recent weather data for London, this evening will be mainly fine with some late warm sunny spells giving way to clear spells overnight. There is a small chance of showers developing in the southern coastal counties later in the night. The minimum temperature is expected to be 11 degrees C. Therefore, it's unlikely to rain in London today, but there is a small chance of showers developing later in the night. And there to provide a source as well. And notice I didn't really even ask for sources. It just did that. And I'm actually opening the source here. So I've pulled that source open. And let's just have a look. Just making sure we haven't hallucinated anything. So yeah, there's no rain in London today. The minimum temperature expected at 11 degrees C. I want to see where we're pulling that from. did mention it somewhere. There you go. Yeah, so minimum temperature expected 11 degrees. So that worked well for that simple internet search query question. And you can see how flexible this workflow is already, especially compared to the a workflow where you just define static agents that just do one thing all the time. Let's try something else. Please, could you summarize the new mixture of agents framework for me? I won't ask it to do the paper specifically, just to see if it does converge this time around. And let's say, please use sources from the internet to spell internet wrong, but it should be clever enough to know that. So we're jumping back into our expert internet researcher. We've got a tool expert there. Let's see what comes back. So we are scraping. And, you've got to remember these agent frameworks, they're really only as good as their tools. There are obviously limits to the reasoning and planning capacities of large language models, but even as the models get better, if your tools aren't very good, in this case, my tools aren't the best because of the way I've coded them up. I haven't really bought into it lots. This time around, seems this looks more like a paper. This is just a long article, not a paper. I can see the source there. But yeah, what I was saying is I haven't really put much thought into my tools. If you put more thought into your tools, the quality of responses you're going to get back is going to be better. This is kind of like a brute force approach. There's ways you can definitely improve this. So we have it has converged this time. So we've got a final answer. The mixture of agents MOA framework introduced by Together AI represents a significant advancement in artificial intelligence by leveraging the collective strength of multiple large language models to enhance quality and performance. Here are the key points of the framework: layered architecture, collaborative approach. They talk about the benchmark performance as well. So they achieved remarkable performance on multiple benchmarks. And they talk about these benchmarks, cost effectiveness, open source contributions. And there we go. We have the research paper linked here. Let's see if we pull that up. There we go. Mixture of agents. We have the GitHub repository. And that's Together Computer, mixture of agents. Their repo has 2.1 stars. And we have the Together AI blog post about a mixture of agents. So it does look like this time around it worked. And that was just from me being a bit more clear with my prompt. But that just suggests to me that the meta prompts that I've written needs to be a bit clearer, and the way that the meta agent communicates with the internet search agent could be improved as well. And that could be improved by improving the internet search agent's functionality. Right. So I want to talk about some strengths and weaknesses of this meta prompting approach and where I think it's heading in the future. So stay tuned if you're interested in hearing that. That was my implementation of the meta prompting agent. Now I just want to talk through some of my opinions on where I think these type of agent frameworks are going, especially this meta prompting, specifically the meta prompting framework. And also, I'd like to just highlight some of the strengths and weaknesses pointed out by the research paper. So the first thing to say is that I think this research paper came out in January 2024. Since then, we've obviously had the release of models like GPT-4 Omni and Claude 3.5 Sonnet. So all of the conclusions from this paper were based on GPT-4, which is obviously an older and less capable model than the ones we're using today. So one of the things they mention in the research paper is that using this meta prompting approach does actually surpass standard prompting and dynamic prompting. And there's some figures mentioned here. Now, if you want to get into the details of that, feel free to read the research paper. I will link it in the description to this video, but it is suggesting that on certain tasks that they tested, the meta prompting approach does surpass standard prompting, dynamic prompting, and they also benchmarked against multi-persona prompting. But have a look at the research paper because it will go into more details about exactly how they set those tests up. The key thing I want to address here is weaknesses, because many of you will be looking to see how you can integrate this into business workflows or see if there's any legs in this to actually build products. So one of the top weaknesses they identify is cost inefficiency. So remember, when they were building this meta prompting, when they were doing this meta prompting research, they were using GPT-4, which was incredibly expensive. Since then, we've had not only more performant models, but the cost per token has come down for those models. And if that trajectory continues, we're going to be able to see even more powerful workflows, because the things you'll be able to do to make these workflows work. So I'm using meta prompting in this example, but there's no reason why, if you had fast and cheap models, you couldn't mix in mixture of agents at the meta prompt level to get the best possible prompt for your experts. Or you could even have mixture of agents across all of the experts, for example, if models were cheap enough to do that. There's also no reason why your experts couldn't be smaller models. So open source models, 8 billion size models. So if your expert's just doing something like classification, for example, could be a small model that's just specialized for that classification task, for example. So that's on the cost inefficiency part. The scalability issues part. So what they say is it requires large scale models with extensive context windows. So that is true. It says limiting the use of smaller models like ChatGPT. I think that's wrong, just smaller models. That's just my note taking. So yes, the meta prompter does need to have two criteria. So it needs to have a large context window, and it does need to be a state-of-the-art model. And that's because it's having to decide for all of the other experts, based on the collective knowledge gained from the experts, what's the right course of action to take. And yes, that's reasoning. That requires a decent level of reasoning that smaller models might not have. And I've seen it myself. I've tried to use this meta prompting implementation with Llama 70B, and that didn't work. I've tried to use it with Mixtral, and it didn't work too well either. I've only really gotten it to work with Sonnet and Omni. So they mention things about linear operations here as well. There are sequential aspects to it, because obviously you have to have your expert come up with the prompt for, your meta expert or your meta agent come up with the prompts for your expert. So there's linearity there, in the sense of you can't really skip that. Your meta expert has to come up with a prompt first, and then it has to pass it sequentially to an expert. And then it has to wait for the expert to return a response before it can evaluate it. So there is kind of linearity in the meta prompting approach there, which could slow things down. But with faster chips, we might be able to do that in a speedy way. So the domain restrictions part is just saying that you can't put this workflow into effect for just an unbounded problem. It works best where there are certain boundaries and constraints to the domain you're operating in. So I did try this. So I tried to get the meta expert to be able to create experts that weren't in the prompt. And I found that it couldn't do that. So that was kind of a way of removing that domain restriction and seeing if the framework did work. And I saw that from the examples I ran, I was never able to get it to actually create an expert that wasn't already mentioned there. So I think you have to have a defined set of experts. And I think that's the way it works best. And also providing that in context learning as well. So that helps to further constrain the domain. Information transfer challenges. I found this in general with a lot of multi-agent workflows. Sometimes things just get lost within the context, but I believe that they're starting to solve some of those problems with long context windows. So earlier on, when the long context windows started first appearing, so I remember the first Google Bard, I think, had a long context window. There was a paper that came out, I think it was called Missing in the Middle, and it basically said that large language models, when dealing with long context, they tend to be able to pick things up at the start of the context well and at the end of the context well, but the performance drops off in the middle. So they lose some of the context in the middle. And I think there are techniques now that have been released since that are making that a bit better. So they're starting to be able to perform better at picking things up in the middle of long context. And that's going to be key for any agent workflows, because the more context you can give a meta agent, the better it's going to perform. So response patterns, I didn't tend to find that it was too apologetic, but I guess that is with a weaker model. If it's unable to kind of generate the meta prompt or understand the context that's being fed to it, it might do that. Or depending on how it was fine-tuned as well. Some RLHF fine-tunes make these models very PC and that sort of thing. But I didn't find that personally. Limited parallelism. So we've already talked about that in terms of having that kind of sequential approach. Context management. So I'm using the state to manage the context. I'm using the state to manage the context. So that's a artifact of the LangGraph framework. But if you don't do that effectively, you're not going to be able to get the agents to communicate with each other well. So it's saying lack of efficient history, summarization, or refinement between steps. I think there is something to be said about that, especially when you're scraping long bits of context from the internet. Part of me wonders if there is a way to do this with RAG. So instead of just going to the internet and scraping the entire web page, you scrape it and then embed it, chunk it, embed it, and then run a retrieval model over it, retrieve the things that are relevant based on the prompt. That obviously adds latency to the system, but it might be a way to effectively manage the context more, and it might even help the meta prompter or the meta agent to be able to generate better prompts, because it's not just reading a large block of text, it's actually reading the things that are relevant from that scraped data. So it might be something I do an experiment with. Let me know in the comments section if you'd like to see that. But yeah, that's a way of effectively managing context. And then model dependency. Yeah, obviously, to do any type of meta prompting, you are going to be relying on these super powerful models that are proprietary to places like OpenAI or Anthropic or Google. I don't know how far open source models are behind those models, but I doubt we're going to be in a position where the best open source model is going to be outcompeting GPT-4 Omni. Right, in maybe in a few months it will, but right now it's not. The models are coming out. Open source is kind of tending towards smaller, more performant models for specific tasks, smaller and efficient models for specific tasks, rather than trying to release massive models that are kind of generalist models. That seems to be well in the domain of the proprietary model companies, so the big tech companies like Google and the likes of those. So yeah, there is a dependency on those highly performant generalist models. And that just brings me on to where I think this is going. I can see scenarios where you have one huge model that operates in the cloud, for example. So, and it's provided to you by an OpenAI or an Anthropic or whatever. And that is acting as the meta prompter. And then you have several smaller models or experts that do certain things on your device. And some of those experts might even run locally. And the idea is you communicate with the larger model, but everything is the experts are running on your local device, for example. So it might even do things like, I don't know, document classification in your in the documents on your device. And because the model is running on your local device, you're not sharing those documents out to OpenAI. OpenAI is just the expert or the meta expert generating the meta prompt that talks to your models that run locally. So I can see architectures like that coming in the future. I can see the meta expert being able to do a lot more and manage a lot more experts as A, model context windows grow, B, reasoning capabilities of those models grow, and C, the token cost per token generation and cost of input tokens reduces as well. So you can see how these meta experts become way more powerful and able to control experts on your machine or even other experts on other clouds, let's say, to do quite sophisticated things. The other thing I think will really come into play here is fine-tuning. So I think having your generalist meta prompter is going to be great, but having a small model that is fine-tuned on one task, let's say you are a business and you need to like have a process where you're classifying invoices. Let's just say, I don't know if that process exists for some businesses, but let's just say, and you have a specific, unique way of creating your invoices. You might be able to fine tune, or you will be able to fine tune a small model locally on your machine that is just really good at classifying your invoices for your business. And then you prompt the meta prompter to tell it to classify those invoices in certain ways if you need it to be flexible. And you might have many of these types of of models locally, right? So it might not just you might have one for invoice classification. You might have another that generates emails in a specific way. You might have another that's fine-tuned to talk to your customers, but they're all controlled by this meta prompter. So that's kind of where I see it going. The fine-tuning aspect is going to become really handy for those expert models. Now, obviously, these are all my opinions based on some of the research I've done, based on clients I've spoken to, based on things I have built myself. Let me know your opinions in the comments section. If you enjoy this content, don't forget to subscribe to the channel for more large language model and AI engineering content. Thanks for tuning in again, and I look forward to seeing you on the next video.